Hey guys, a quick update on the ventilator project that I'm working on with my colleague Mihai. We did quite some progress and we managed to make this system more stable, and I will show you what I did, and I also upload the files on GitHub. We changed a few things on the hardware side and on the software. And yeah, let me show you what we did. So after posting the project, I've got some requests that we should make the hardware two-part control. So we have the controller, and then we'll have an API, like similar what we did to a different project. Having it controlled by API, and no matter what happens with the user interface, the machine should still go on. So we changed from the Arduino Nano to TNZ board 3.2. It's a bit more expensive, but it feels like it's more trustful. I don't know, the processing speed it's also much higher. It can control the stepper motors a lot more precisely. I think Arduino will do fine as well for this kind of project when you do it yourself at home and stuff like that. But in case it is going to be used to be produced in any country, like you will want a better ICU. So additionally to the board, we also added the pressure sensors. Those will be connected to the output of the so I'm using this PIP valve to test that it can push the pressure. It has a maximum of 20 centimeter setting here, but I think it's going to be around 30 at this point, and it's pushing fine. So what we'll do with these two sensors, I'll add the details in the README file on GitHub about which kind of sensors we used. We'll use a Venturi valve to measure the volume of air that's going through the output here, and we'll also be able to measure the pressure inside this chamber here. So right now I'm printing the Venturi valve. Tomorrow I should have it as well. After that we'll connect some hose with the mask and have the oxygen mixing as well. It will be on the back here. This ambu bag comes with an expansion bag where the oxygen will sit to go. It's not going to be your emergency breathing machine that you have in the hospitals, but the purpose of this project is to supply the need of this kind of machines. So let me disconnect this for a second. We also chose a different driver, one that's more compact and it's better suited for this project. I changed the way that the belt is being tensioned, added the small tensioning here, and I also added the limit switch right here, so it's close to the working area actually. So because before I had some dead movement happening, and in case you click on this, it's going to home to get this position, and then it will return with the settings that it had saved. So in case the belt moves and it loses some steps, when it's going back, it's going to hit the switch, home itself again, and go on. I know it's not 100% precise with the belt and stuff, but this is the most easy way I found to make this movement working properly and have it working with parts from regular 3D printers and stuff like that. So let me show you what control we have so far. I'll put the camera down for a sec. Alright, so let me open a console here. Start the board. Alright. It was because I had it connected and disconnected from serial. Okay, so this is the API that I actually had at the moment. You control these two parameters. Before I had it some weird way for testing stuff in percentage, and people complain that doctors don't use percentages, and they were right. So I made it to look like what the doctor would use. So if you want 20 breaths per minute and you want the inhale exhale rate, and I also explain what that means because I saw others working on controllers and they got it wrong. So this is how it looks, and I'm printing the times to check the motor speeds for inhale and exhale. So let's see. Let's go crazy, like 30 breaths per minute. So let's get something that's more likely to be used, like 15. So like I was saying, the inhale and exhale rate, it means how much time it has to push the air into the lungs and how much time to exhale it. So for example, if you have 12 breaths per minute, that means you have one cycle for each 5 seconds. And what you do, in case you have 1 and 1 inhale and exhale rate, you will have half the time inhaling and half the time exhaling. When you have a rate set to 1 and 2, so you have to divide the total time, so you'll divide 5 seconds, let's take 6 because it's easier to calculate. So you'll divide 6 seconds to 3, and then you have 2 seconds to inhale and 4 seconds to exhale. You do the same thing for 1 and 3 ratio. You divide it by 4, and then you will have 20% of the time inhaling and the other 75% exhaling. So that's how I checked a few videos on how mechanical ventilators work, and they explained all the settings and the modes that it should work. And after we put these pressure sensors here, we'll get some access to more advanced algorithms to make this like support breathing when the user tries to inhale it can trigger the machine. It's going to get more advanced, but I hope if this is going to be useful for the people, we'll get some more advanced programmers joining and implementing these algorithms, or finding a way to get access to some source code from other machines, so we don't have to test the algorithms and stuff like that. They are already into the machines that exist, so that's another option. If we get something, or if you guys know some open source project or something like that, like that's similar to this thing, to get some of these algorithms that we just replace the values there and see that they work. They are proven. They have a lot of checks to see if they have, for example, if you are set on supporting breathing, you still want to have a minimum amount of breaths per minute in case the user doesn't try to breathe or stuff like that. You still push air into him to keep him alive. So yeah, that's the status of the project at this point. Like I said, I will make it up. I made it already. I placed it on GitHub. I will push the new code with the Teensy board. This code should work on the Arduino as well. I did not change anything. It's still written in Arduino. It's the fastest way for me to develop, and once all the code is tested and it works as it should be, it can be translated in C or C++ easily by a programmer that does that every day. Because for me it's going to be overkill to try to implement this and have the user interface going as well. That will be written in Python, and will send commands to the board. So thanks for watching, guys. I wish you all the best, and if you have any questions, don't hesitate to contact me. I will try my best to make the files available in whichever format you can check, because I had a user from Pakistan saying that he could not open the files because the SolidWorks version that I'm using is 2019 and it's not backward compatible, so the files need to be opened with 2019 as well. But I added the STL files and you have some renders there. Basically, you need to get this movement going. So what you will need is the ambu bag, which comes with this mask. The ambu bag is cool that it has all the valves in place, so you don't have to engineer any valves or 3D print or stuff like that. So it comes like this by default, but you'll have to extend this, like put 1 meter of hose to this. And I purchased some of these PIP valves because I understand that they are needed to treat the patients with pneumonia. So it needs to have a positive pressure when exhaling. So that's what this is used for, to set a positive pressure on it. But we'll also use this as a safety valve. In case the airway is blocked, you don't want to push air, so we can make the spring harder in here, so it goes, it increases the resistance. But at this point, I think it's just fine to be used as a safety valve when you go over the set max value here. So you see the spring is still going a couple of millimeters. So yeah, the oxygen goes here, so you have the port for oxygen. The bag will fill in the back. I don't have it here because it's accommodating. And yeah, I will be posting more videos with the development of this project. If you have any ideas or you want to join that Git project that I did, and you want to add some checks, like do more checks on setting the speed or setting the values there.